The next problem we have is a passenger train speed is 60 miles per hour and a freight train speed is 40 miles per hour. The passenger train travels the same distance in 1.5 hours less time than the freight train. How long does it take each train to make the trip? So what we did, and I made up this table to help organize our thoughts. We have the label, the rate, the time, and the distance, or rate times time equals distance. So the first label we have is the passenger train. If you can guess, the second one would be freight train. Now the passenger's rate or speed in this instance is 60 miles per hour, and the freight train speed is 40 miles per hour. The only thing it mentions about time is that the passenger train travels the same distance in 1.5 hours less time than the freight train. So what we can say is the freight train, whose time we don't know, is just going to be called t for time. What we do know is that the passenger train travels 1.5 hours less time than the freight. So the passenger would be t minus the 1.5 hours time, because that's what it says in our problem. Now, we know that the distances are equal, so we could say the passenger train distance is equal to the freight train distance. So, passenger train distance equals freight train distance. Now, because distance equals rate times time, we can multiply the rate and time for each one to reveal 60 times the quantity t minus 5 and 40 times t for our distances. Again, because we know that they're equal to one another, I could say the passenger train's distance is 60 times the quantity t minus 1.5 equals the freight train's distance, which is just 40 t. So using the distributive property, we're going to find that we have 60t minus 90 equals 40t. Then what we're going to do is we are going to add 90 to both sides. And the reason why I chose to add 90 to both sides as opposed to move the 60 is because what we would want to do eventually is keep our t to be positive, so it makes it easier later. 60t we did not touch. Negative 90 plus 90 goes away. Then we have 40t plus 90. Then in order to isolate the variable or combine like terms, I need to get the t's on the same side, which in this case is the left. So we're going to subtract 40t to both sides. And we are left with 20t equals 90. Divide 20 to both sides. And we get t equals 90/20ths, which is the same thing as 9 halves, or 4.5 hours. The next problem talks about another car. It says, at 10 a.m., a car leaves a house at 60 miles per hour. At the same time, another car leaves the same house at a rate of 50 miles per hour in the opposite direction. At what time will the cars be 330 miles apart? So let's imagine this just for a second, shall we? That we have two cars going in opposite directions. So one car is going to be going west. The other car is going to be going east. What we want to think about is car A, or the first car, goes at 60 miles per hour. Car B goes at 50 miles per hour. Now these two cars are going to be going in the opposite direction until they're 330 miles apart. So if we think about it, if both of these cars are on the road for exactly 1 hour, they're essentially 110 miles apart. So before I move on, let's take a look and fill out our table. We still have label equals rate times distance equals time. The label for the first is car A and car B. The rate of car A is 60 miles per hour and B is 50 miles per hour. The time, they leave at the same time. So their T's, or their time on the road, should be equal to one another. And we're trying to find the distance. So because rate times time equals distance, we can multiply and get the following. Now, like we said earlier, if they were out for 1 mile, we would get 110 miles per hour, which is essentially just adding the two rates, the 60 miles per hour and the 50 miles per hour. So now we know that d sub 1 plus d sub 2 equals distance, which in this case is 330 miles apart. We know the distance 1, or car 1, is 60t plus 50t equals 330. That gives us 110t equals 330. Divide by 110, divide by 110. To get the t by itself, we get t equals 3 hours. So in exactly 3 hours, the two cars will be 330 miles apart. Now it's your turn. So let's look at this problem. A train leaves the station at 6 p.m. traveling west at 80 miles per hour on a parallel track. The second train leaves the station 3 hours later traveling west at 100 miles per hour. At what time will the second train catch up with the first? So what you want to consider while trying this problem is, does this problem match more this second example, where they're going in opposite directions, or the first train example, where they're going in the same direction? So once you're done practicing this problem, please post your answers to Edmodo. The first person to start will begin the thread, and everyone else should just post in that reply box. That's it for now. Thank you guys. See you next time.